Good morning. It's August 5th, and this is your daily brief in science. Here's everything you need to know. A recent study has uncovered notable differences in toll-like receptor expression between patients with squamous cell carcinoma, or SCC, and healthy individuals. This research indicates that these receptors may play a significant role in the progression of cancer. The study focused on measuring TLR expression levels in the peripheral blood lymphocytes of newly diagnosed SCC patients over a 3-year period, comparing the results to those of healthy controls. SCC accounts for 25 to 30% of non-small cell lung cancer cases and is often linked to tobacco use, chronic inflammation, and DNA mutations. The findings revealed a concerning mortality rate among SCC patients, with only 16.42% surviving after 3 years. This high rate is primarily attributed to disease progression and associated complications. The research also emphasizes the potential of systemic inflammation markers and tumor-infiltrating lymphocytes as prognostic indicators in SCC. By focusing on both oral and lung squamous cell carcinoma, the study explores how immune system factors influence overall survival and disease-free survival. Significant differences in TLR expression were noted, with higher levels associated with advanced disease stages and poorer survival outcomes. The research involved a cohort of 67 SCC patients and 40 healthy volunteers, utilizing flow cytometry and enzyme-linked immunosorbent assays to measure TLR levels. The study advocates for further investigation into TLRs to enhance treatment effectiveness and improve clinical outcomes for SCC patients. Researchers have made a groundbreaking discovery in the Clarion-Clipperton zone of the Pacific Ocean, identifying a new form of oxygen production termed dark oxygen. This phenomenon occurs at depths of approximately 4,000 meters in complete darkness, which challenges the long-held belief that only photosynthetic organisms can generate oxygen using sunlight. The seabed nodules responsible for this oxygen production possess a high electric charge, potentially facilitating seawater electrolysis for hydrogen and oxygen generation. These nodules exhibit high electrochemical potentials, reaching up to 0.95 volts, functioning similarly to rock batteries, although they require around 1.5 volts for effective electrolysis. Previously, observations of dark oxygen were dismissed as measurement errors. However, collaborative research efforts have confirmed the validity of this phenomenon. Matthias Heckel from Geomar pointed out that this finding contradicts existing textbooks, which primarily focus on oxygen consumption by microorganisms in deep-sea environments. This discovery raises crucial questions regarding the origins of life on Earth and the potential environmental impacts of deep-sea mining on marine ecosystems. As interest in deep-sea mining grows, there is increasing pressure on the International Seabed Authority, or ISA, to conduct further research and possibly delay new mining projects until the implications of these findings are better understood. The ISA is currently facing scrutiny regarding its structure, with concerns about leadership and the balance of interests between member states that support mining and those advocating for environmental protection. Experts emphasize the urgent need for additional studies to ascertain the ecological significance of this oxygen production and to ensure that regulatory measures for deep-sea mining adequately protect these newly discovered processes. Researchers are turning to a new approach in greenhouse gas monitoring, seeking alternatives to traditional technologies that are often costly and complex. This shift focuses on metal oxide semiconductor, or MOS-based sensors, which promise a simpler solution. A significant challenge with these sensors is humidity, which can severely impact their performance in both environmental monitoring and medical diagnostics. A recent study delves into how adsorbed water affects the conductivity of two materials, pure tin oxide and a mixture of tin, titanium, and niobium oxides. The findings reveal that the Sentien BXO2 sensors show reduced sensitivity to humidity compared to pure tin oxide, making them more viable for applications where humidity plays a crucial role. Sensing tests have demonstrated that these sensors are more sensitive to methane than to carbon dioxide, with distinct saturation behaviors observed at increasing methane concentrations. Temperature also plays a key role in sensor sensitivity to ambient gases, as experimental analysis at various temperatures indicates. The research further investigates optimizing sensing properties based on factors like synthesis method, operating temperature, and electrode geometry. Notably, the electrode gap is a critical factor, with smaller gaps enhancing sensitivity for certain materials. In the study, powders were deposited on alumina substrates with platinum interdigital electrodes featuring gaps of 200 micrometers and 100 micrometers. Additionally, surface area and porosity analysis using nitrogen adsorption-desorption isotherms showed that the co-precipitation method yielded a higher surface area and mesoporosity compared to hydrothermal growth. The co-precipitation method produced uniform quasi-spherical nanoparticles around 6 nanometers, while the hydrothermal method resulted in larger irregular nanoparticles approximately 42 nanometers in size. This research aims to clarify the controversial mechanisms of water surface interactions with these materials, bolstered by theoretical studies from existing literature. Municipal wastewater treatment plants across the United States generate approximately 8 million tons of dry biosolids each year. This trend is mirrored in the European Union and China, raising significant environmental and health concerns. The increasing production of biosolids is problematic due to the presence of pathogens, trace pollutants, and heavy metals, which can pose risks to public health and ecosystems. Disposal of municipal sewage sludge presents considerable environmental challenges, primarily due to contamination from both inorganic and organic pollutants. Traditional methods of managing biosolids, such as landfilling and incineration, contribute to environmental issues, including methane emissions and potential groundwater contamination. While there is potential in using biochar derived from municipal sewage sludge, it often contains elevated levels of heavy metals, complicating its application. The widespread use of biosolid-derived biochar faces hurdles, including the need for standardized production methods and addressing heavy metal contamination. Additionally, the economic feasibility of these practices must be assessed. A review of various pyrolysis processes, slow, fast, and flash, has shown that these methods can convert biosolids into biochar, which may positively impact soil health and crop productivity. The quality of the biochar produced is significantly influenced by factors such as the type of co-substrate, mixing ratios, and pyrolysis temperature. Co-pyrolysis not only enhances the properties of biochar, but also helps mitigate risks associated with micropollutants found in municipal sewage sludge biochar. Future research should focus on optimizing pyrolysis conditions, developing regulatory frameworks, and conducting economic analyses to promote sustainable agricultural practices. It's important to note that biosolid management practices vary globally, with developed countries often utilizing advanced technologies, while developing nations face challenges due to inadequate infrastructure. A recent study has unveiled a surprising link between a specific bacterium and obesity, opening new avenues for understanding this complex health issue. Conducted by researchers from Rujin Hospital, BGI Research, and the BGI Genomics Institute of Intelligent Medical Research, the study highlights the potential role of the bacterium Megamonas in contributing to obesity. The research involved metagenomic sequencing of fecal samples from 1,005 participants, which included 631 individuals classified as obese and 374 of normal weight. This comprehensive analysis revealed that gut microbial imbalance is particularly influential in obesity among those with low genetic risk, suggesting that environmental factors may play a significant role. Results showed a marked increase in megamonas within the intestines of obese participants. Notably, higher body mass index and obesity rates were associated with a megamonas-dominated enterotype, indicating a potential microbial signature for obesity. The study concluded that megamonas interacts with host genetic risk factors, particularly heightening the likelihood of obesity in individuals with low genetic predisposition. Dr. Yang Fangming, a co-first author of the study, explained that megamonas degrades myoinositol, a process that enhances lipid absorption, thereby linking this bacterium to obesity. This degradation process facilitates intestinal fat absorption, further solidifying the connection between megamonas and obesity. BGI Genomics, a prominent player in precision medicine based in Shenzhen, China, was instrumental in this research, which spans over 100 countries, highlighting its global impact on health and science. This has been your Daily Brief in Science. To read more about these stories, follow the links in the episode bio. You can also subscribe to these updates via email at www.brief.news. For more daily podcasts about the topics you love, visit brief.news/podcasts. Tune in tomorrow. We'll be back with everything you need to know.